This is the titanoboa, one of the largest and deadliest snakes to ever exist. It went extinct 55 million years ago, but what if that never happened? This is What If, and here's what would happen if the... Okay, before we look at the modern day titanoboa, we need to go back. 60 million years ago, the titanoboa lived in the tropical waters of South America, arriving on the scene after the dinosaurs went extinct. It was a major predator of its time. This snake was unimaginably large. It had a girth of about 1 meter that would come up to your waist. It was 14 to 15 meters long, and it weighed over 1,000 kilograms. Luckily, it had a different way of killing its victims. By wrapping itself around your body or squeezing your windpipe, and then swallowing you whole. It allowed it to camouflage itself in its swampy environment. It would sit and wait for the perfect moment to strike. It feasted mainly on fish, turtles, and crocodiles. So, if the titanoboa was so dominant, what finally made it go extinct? Well, it had to do with a massive change in climate. But to understand this, let's first dive into what made the titanoboa such a dominant creature. Paleocene. Dive into what made the titanoboa such a dominant creature, and then how it suddenly went extinct. Paleocene. 66 million years ago to 56 million years ago. Titanoboas emerged after the apex predator niche was left empty by the extinction of the dinosaurs. They thrived in hot and humid environments. Lucky for them, that's what Earth happened to be like 60 million years ago. The average temperature was around 24-25 degrees Celsius. Ice caps, the poles were covered with forests, and instead of polar bears, there were alligators roaming around. There's a set of animals that thrive in the heat, cold-blooded ones. Our titanoboa was cold-blooded, so it loved warm weather. Unlike warm-blooded creatures, cold-blooded animals aren't able to regulate their own body temperature. They use heat from the environment to warm up their bodies and kick their metabolism into a higher gear. So a warmer Earth was perfect for the titanoboa. It had a supply of external energy to keep its body warm, hunt without mercy, and become one of the largest predators ever. Earth experienced two very different climate shifts. First, it became very hot, and then it cooled down. With our current evidence, it's not clear if the titanoboa became extinct during the heat spike or during the cooling phase. The heat and became a great food source for the titanoboa. So in this scenario, our titanoboa just gets bigger and badder during the heat spike. As the heat spike was so sudden, oceans absorbing carbon dioxide would have become more acidic. Many fish may have died in that acidic warm water, which would have meant fewer fish for the titanoboa to eat. Now, moving on to land would have been titanoboa's best bet. As Earth became warmer, something interesting was happening. Above the waterline, the land was exploding with different types of mammals. Camels, horses, pigs, goats, and giraffes all evolved when Earth was a giant sauna. So, it would have found some new foods to keep it going. But because of its large size, living on land would have been difficult. Snake is going to get some stronger swimming muscles and swim up to the poles. Because around 50 million years ago, temperatures began dropping in a long-term cooling trend that lasted until the dawn of civilization. The once lush forests at the poles are now becoming ice caps. Cooler climate didn't suit this cold-blooded snake. It could no longer get the heat it needed from the environment to be able to power itself. It's possible that this led to the titanoboa's extinction about 55 million years ago. In our hypothetical scenario, the titanoboa becomes warm-blooded. It's true that if we look at snakes, we don't see any examples of them being warm-blooded, but it works. Let's use a shark as an example. Now, the muscles they use to swim generate heat, which heats blood in the veins. The arteries bring cold, oxygenated blood from the gills to the shark's muscles and organs. This cold blood picks up the heat from blood in the veins, which then raises the shark's internal temperature. But In the titanoboa's case, there are no gills involved. It breathes. We can make it warm-blooded like the shark by having cold blood pumped in through the arteries, which then pick up the heat from the warm blood in the veins. This single evolutionary transformation would allow the titanoboa to survive the mass cooling. Let's see what happened. During the Miocene epoch that followed, Earth began to warm a little, followed again by a period of cooling. The climate became drier and vegetation was more coarse. Also, a saber-toothed cat-like creature called the nimravid roamed around. I know I said that living on land would be tough for such a massive creature. To camouflage in the desert, it would need to adapt a new color scheme, a light, sandy color. And it's the first able to preserve its body heat through adaptations that make it warm-blooded. And the second is also warm-blooded, but lives in burrows deep in the desert. These 21st century titanoboas would be as long as 23 meters and about 1.2 meters wide. Imagine going for a swim in the ocean and running into one of those. You'd have just enough time for one last breath. 6,000 years ago to today. Now, this was the start of modern hunting. Titanoboas would have been legendary, frightening sea creatures that terrified humans. Swim could be your last if you encountered a titanoboa. The only good news would have been that these enormous creatures would probably have little interest in eating you. Because the boa was still around, it may have been a target of fishermen thousands of years ago. Hear about rare titanoboa attacks on humans who swam too far out into the ocean. In the desert, nomadic tribes would probably fear the random, unpredictable attacks of the desert titanoboa. Camel activity has reversed the cooling trend.